Okay, titration. This is a way that you have one sample that you don't know the concentration of, and you react it with another sample, knowing its concentration and its volume, and you can get the concentration of the unknown sample. So you're going to get a nice laugh because I'm going to make a little sketch for you. All right. So in a beaker or a flask, you put your acid of unknown concentration. Okay? You add an indicator. That is actually optional. It's going to give a color change to help you see the end point. But when we're using a lab quest and pH probe, you don't need it. Okay? So we're going to do this in a beaker because our setup's going to get pretty crowded in here, because we're going to have our pH probe, and then in a burette, which is a long skinny tube marked like a graduated cylinder. With a stopcock at the bottom. So you can adjust the amount you add. Okay? So you're going to drip solution in that you know the concentration of from the burette until neutralization has occurred. So how would we do one of these calculations? So this is our known in the burette, and then this is our unknown. Okay? We know from our balanced equation that these coefficients, remember, tell us moles. So we know that for every 1 mole of H2SO4, there are 2 moles of NaOH. So we're going to do some stoichiometry. Well, we know that molarity equals moles per liter. Well, that's also the same as millimoles per milliliter. As long as we add the same prefix to the top and the bottom, the ratio still works. It's nice to use that because then we don't have to convert from milliliters to liters. So we have 18 milliliters times 1 mole per liter. This is of our NaOH. Always label. And we know that there are 2 moles of NaOH for each 1 mole of H2SO4. So that's going to give us 9 moles of H2SO4. So molarity, 9 moles divided by 25 milliliters gives us a molarity of 0.36. Okay? And then this is just the exact same calculation typed out.